Welcome back. We are done with we are done with we are done with modeling. Now we want to go to see how the loads are. Now to again under the tree menu, we now come to static loads. Of course, we have different load system here. When you come up into this area here and look at the load, there are various. They have the static loads. Under the static load, you have the self-weight, load masses, you have hydrostatic pressure, element loading, all that. You have to go state temperature loads. You have moving load for traffic. You have and the traffic different. South African one, Russian one, Poland, Korea, Eurocode, British settlement loading, load table. All these are all here. But now down we already have the loading. They are already specified. We have the self-weight. We have your self-weight here. This is very important. You have to have your self-weight here. And then you have to have zero weight is indicated here. Then the next load that you need is the wet concrete. These are all construction stage load when at every stage is being captured. And then the formwork is also specified here. You can display and have a look at. Even the wet concrete you can display to have a look at. All that once you enter that in the wizard, we shall do a wizard the model and you see where we apply this. I will get the time, but for now I'm just taking through what was done. And then you have element of formwork I've given. Barrier loads, you can see how it appear on the edge. So you have your barrier load. You need to know the shape, you need to know the material component, the unit weight. You have to calculate that. You calculate it. I've been telling you that all the thing you first do your desk work and then you input this value. Even when you are doing from the wizard doesn't just give you automatically. The value which are there are for the software engineers to do their software design and other things. You now as a practical engineer, now you input what is in what relates to your project, what relates to the bridge you are designing. So these backup barriers are given. Additional loads are also there. You may find that you have water pipe running at the edge there, or anything you have on the edge. You define the load and the location. So here you find it was at more or less at 1 meter from, because the definition is from maybe left to right. So you find it was defined there, and then you come to utility. No, wearing surface, the whole thing covered. So you assume that the entire width. Sometimes you make sure you do an effective, because if you have a crash barrier, so your wearing cost doesn't go to the extent. But as a design engineer, sometimes that little offset doesn't affect much, but it helps in terms of factor of safety. And then when you come to utility, you're going to find, now you see to utility it is put on one side, and then the other additional load is, so it's also in the way balanced. So now when water people or telecommunication companies want to clip their services across, you have taken care of during the design. Pre-stressed system, this is not a pre-stressed, this is reinforced concrete, though precast. Then the temperature loading also has to, you have to make sure it is, you have it here. These are the element temperature. Then you have the temperature gradient also specified in line with the code. All that have to be done, you specify. Now if you have the bridge in the northern Uganda region, the temperature there is different from when you are here in Buganda here, or in central, or when you're in the east, or when you're in the south. So you have to be, that's why the use of national annex is very important. It tends to, this is the water, the stream flow current. Normally can be tapering, but for this case I think made it uniform with the speed assumed to be 10, or just going on the higher side, because sometimes this thing flow with debris and can affect that. And also I think you also make assumption that the end of the pier cap is square, so that the factor is higher. Otherwise, if it is shaped like triangulated, then the factor tend to go on the lower side. But we don't have control in practice what happens when water is flowing. Sometimes it flows with trees, so you have to be careful. So as an engineer, a slight increase, slightly higher, will give you some comfort and you can afford to sleep. And then even earthquake, very important. Earthquake also is important. Nominal earthquake specified. You have to look at all this. You find that I've given all these parameters. Normally, it is very important that the input from seismologist is very important, and geotechnical, because the ground parameter must also be known. So these are things that we need to know. Then the traffic loading. The traffic loading is very important. You do the traffic, what traffic you are doing, then you define the lane, then you define the traffic, the trucks, the vehicles themselves are here. You do the load type 1, load type 2, load type 3, all that, and these factors are very important, especially for LM1 and tandem system. So you make sure you have all these load applies, and then settlement also, you indicate some settlement loading. That's because sometimes this thing go, if it is pile, I think about 10 millimeter, if it is a spread footing, about 20-25. So that is what happened with the loading. You have to make sure you apply all this loading correctly. But with the use of wizard, most of this loading, like the dead load, superimposed dead load, are already specified, and we are able to use it. So when we are doing that first principle definition, kind of, we shall have a look at that. This is an explanatory session whereby we're taking you through what was done. Thank you.